presentation is about advanced threat modeling, integrated approach for security design and test automation. This is by Sriharsha Narayanam and Sumit Agarwal from Huawei Technologies. Over to you.
Uh, Thank you, Samiksha. Good morning, everyone. Welcome to the first track session. So here myself, so this topic is about advanced threat, as Samiksha mentioned, advanced threat modeling, integrated approach for security design and test automation. So this will be presented by myself, Sriharsha Narayanam and Sumit Agarwal. We both are from Huawei Technologies. So I work in a center of excellence team in a range of areas like cybersecurity, DevOps, and open source. Sumit works on a cloud database and application development and design and security and other capabilities. So let's get started. So this is our agenda today. So first we will share the background and challenges, like what are the key challenges, why this specific thing is different, and what is that we are trying to solve. And then we'll move on to the framework overall view, and we'll talk about the threat pattern library industry differences which others can take away from this, and privacy protection controls. Then we'll give a system walkthrough, whatever the system we are talking about. Sumit will give us a system walkthrough, and then we'll talk about the attack tree analysis, how it is different from a general attack path analysis, and test scenario generation and automation. This is the whole flow we'll go through today. So to start with, let's talk about the engineering of attack. Okay. So what is threat modeling? If you see the threat modeling or any other cybersecurity analysis to ensure the security of a product, so it is very, very important to understand the perspective of the attacker. Like, what is the attacker's thought process? What is his technique? What is his tactic? What is his procedure to attack the system? If you know these aspects, actually, so we can very well secure our products. So that's a whole idea behind the and these analysis. So if you see here, so first is known threat actors, the attackers, and then attack patterns. This is common attack pattern enumeration and capabilities. Then, so each of the attack pattern is just a high level thing. Like, what is a pattern? Will he choose like a command injection, or will he choose what kind of a like input exploitation will he choose? Like, all that kind of things will come into the attack patterns actually. Then weaknesses, what kind of a weaknesses will enable these attack patterns to get realized, and what kind of a controls we can include in our system to safeguard, like mitigations and security design perspective, and then tooling perspective we can include, so that we can safeguard our technical assets from the technical and operational impact. So that's a key point here. So all the analysis what we have in cybersecurity primarily will be based on this. So it is mainly the attacker's perspective. Just to see here one simple example. So command injection, in that subcategories as SQL injection, in that the weakness is that input sanitization, like whether the input is properly checked or not. So we have the common attack patterns, and then common weakness enumeration and common vulnerabilities. So this is the high level background of it. So when we go back to the traditional threat modeling strike, so what is it we are doing? And next slide we'll talk about what gaps or what challenges usually teams face when following the traditional threat modeling. So I think most of us already know the basic threat modeling, how it is done, and then what is the primary goal of it and all that. So if you see, we just put a simple flow so that to bring all of us in same context. So first we analyze the system components and as per the elements available in the data flow diagram, like external process, data store, data flow and all. Then we visualize the deployment architecture. Then we identify the trust boundaries, like where we are exposed to the attacker in several ways, or what are the possible avenues to get attacked. And from there, we identify the threats and vulnerabilities. From there, for each of these threats and vulnerabilities, what is the level of risk our system is exposed to? And what are the mitigations and what security requirements we can implement to avoid this kind of a risk exposure. And finally, the validation part from the test perspective. This is a typical flow. So basically, threat modeling is a proactive approach to uncover some of the vulnerabilities which are there in the system, right? So it is a stride is one of the way. There are some other ways also. Stride is most popular way. So here we talk about spoofing, tampering, repudiation, information disclosure, denial. So all this we know. So here for the threat modeling as such, the concept as such, the threat modeling, right? So we can say this book is one of the best book actually. If somebody is interested, please go through like how to apply threat modeling as such in a holistic manner. It's from Adam Shostak. So that is one thing, and then let's move on. Okay. So what are the challenges? So we saw the threat modeling, how it is done and all that, right? What are the key challenges with this threat modeling if it is done that way? Okay. What we have faced, rather, I would not say it is a general challenge. Okay. So what we have faced is when threat modeling is done at a design phase, then for each of the threats, what we have identified, so we need to see what kind of vulnerabilities we are exposed to and what is the risk level and what is the mitigation. All that we have to manually identify with the industry references. This is a manual job. So of course there are some security requirements which will come out of it, and then also this will become a primary reference for the test where we derive the test scenarios based on the threat modeling, right? And then some of them will be automated and some of them will be executed using some of the tools, so which we need to deploy separately and then execute. So if you see the key problem here, actually, one is manual effort for the threat intelligence mapping and test scenario derivation will be higher because we have to understand the latest threats and then what are the recommended mitigations and all. And also the automation and tools integration will be actually delayed towards a far right, that is towards fag end actually, so towards a test thing. And also it is if there is a change, for example, you consider that already we have done the threat modeling, already identified the scenarios, everything. Then after that, there is a change in the design, okay, or the requirements. So in that case, threat modeling has to be updated, right? So in after that, how fast we can take it to all this flow, that is also a challenge, isn't it? So we have to do some of the manual work to understand like what impact and all that. So these are the three primary challenges that we have faced some time back. So here I have just put up a industry reference actually. This is a state of DevOps report from Splunk actually. And so if you see the lower right quadrant, actually these are the challenges, top challenges they have listed from a cybersecurity practice strengthening perspective. So you can see here, security and dev teams collaborate on the threat modeling. That is one thing. Whether if it is not done, it is a challenge. So most teams reported this. Security expert evaluate automated tests. Security tools integration to the dev ecosystem can be implemented. So this in the development phase, if it is not done, so probably we are delaying it towards the right. So and then change management. So how the change. So these are the pretty much the problems what we have also seen. Now this being the problem, okay, I'll just first introduce what is the framework, overall framework for that approach we have taken, and how is it different from others actually. So this is the overall framework. So basically the key differentiators here is, you can see, I'll just take you through the flow and then explain the differentiator. So one is that business specific data flow, design diagrams are kept in a separate repository, and the once the data flow diagrams are created, so we can choose based on the type of application, based on the type of the product. So the template can readily be applied, and then it will be like some 60% of the effort will be saved here. From that we can build, and then change identification if it is we are doing a change analysis here. And so here you can see that we have analyze, identify, and execute phase, right? So overlapping all these phases like threat analysis, attack path, risk analysis, risk assessment, mitigation, and scenarios and automate, right? All these areas, the integrated threat intelligence and knowledge base has been integrated to the tool itself. So what is the threat intelligence? What kind of a threat intelligence is important when we are doing this kind of analysis? If you see, the threat intelligence can range from privacy threats, common privacy threats, test scenarios, and product-based, so product-based top-end threats, threat mind map, and tactics, techniques of the attack, known attack patterns, application type based threat, and proposed mitigations, design schemes, latest data from the industry. So these are all, if it is integrated, think about it actually. So we have several references. In the next slide I'll be showing, we have several references for these things. If all these are integrated and can be used by one click, can be imported and used in a one click, So that will definitely ease up. That's what has happened when we have done this actually. So okay, one more important point I just want to make is through this presentation, right, we have also thought about some system we have implemented in our organization. But if you if you have to take away some things to directly apply, we have also thought about and given some industry references where that can simulate similar kind of a framework. So which in subsequent slides we'll see. So here the key differentiators are integrated adaptive intelligence, and yeah, that's what we spoken about, and threat intelligence, attack pattern library with the latest industry data, and product experience specific learning. So this is the overall framework. Subsequent slides we'll see how this is implemented, right? So one important takeaway for this particular session is that threat pattern library. So okay, I'll just explain a little background actually. So if you see when we are saying we are thinking from an attacker's perspective, so attacker's perspective has a pyramid actually. So that pyramid, if you see lower level, it is hash and then IP, and then there are several things in the pyramid which can be changed by the attacker. Like this time he can attack from one IP, next time he can attack from a different IP. It's very easy to change, right? So it's called pyramid of pain. So in that pyramid of pain, the topmost thing is the tactic, techniques, and procedures. So any attacker, right, like he cannot change the tactic and technique and procedure for an attack. It's very difficult. Once you want to compromise a user credentials, the tactics remain more or less same actually. So the pattern is something like we are trying to understand the common tactics, common techniques, and common procedures. So if you see this MITRE, right, this is one of the best source. This is a community driven initiative. So where all the tactics, techniques, known techniques are continuously updated. You can see the top layer is the tactic, the next layer is the technique, and then you can go into details to understand the procedure of the attacks actually. I'll show that in a while. Then we have common attack patterns, which we discussed, common weakness enumeration, CV, common vulnerability, and some of the other databases. So we have a top 25 software errors from SANS, and then OWASP top 10. And yeah, there is an attack navigator as well. So this I'll be showing now. So if you see here, this is a kind of a panorama, right? So for example, if you are trying to analyze our system and see what is the attack surface we are exposed to, then we have to understand what is the type of our application, whether it's Windows or Mac or this thing, and then what are the types of tactics and techniques applicable for our kind of application, and are we safeguarded for each of these tactics? If not, we need to identify, mark them, and then take a countermeasures, right? So I'll just quickly show one attack navigator part. Okay, so you can see this is the from MITRE matrix where all of the tactics, techniques, and procedures are listed. So this is just for this website is for the information, right? So you can see all the details here. Like if you see elevation, right? So you can see bypass user control, and if you go into the details, they will give what kind of a procedures they can follow to achieve this particular technique, right? So, but this is just an information database. But how to analyze our system? So they have also developed an open source attack navigator, right? So here, if this is the navigator, this is open source. This link is given there. So if you want to analyze your particular system, so the first is like actually we can select what kind of application we are trying to. So for example, we are trying to see the Windows based application. Okay, one second. Yeah, we are trying to see the Windows based application. So some of the things will be eliminated in that. So you are actually talking about abuse of elevation of privilege. So you select this, and then you think this particular this particular thing is already safeguarded. So you can give the score. If you think this is a risk, you can give one score as 0, saying this is an important thing which you need to further check. And you can even give it, comment here like need to improve or something like that. Okay. So this is a collaboratively a team can analyze this at the end, right? So once, for example, domain trust discovery. For this, if I give a different score, so the color coding, everything is will be taken care. Actually, we can give a different color code for this. Okay. So basically here we can give it a low. And so this analysis is very good, and we can also export this to Excel, and we can export this to JSON, and then import it to a different system in a way what we want and all that. So this is one thing I would say is a good way to understand the attack surface which our system is exposed to. Okay. Switching back, okay, this is some of the industry references, right? Okay. Now we'll talk about the privacy. So why privacy? Usually the stride, right? It talks about spoofing, tampering, elevation of privilege, and all that, right? It doesn't talk about privacy especially, but the importance of privacy is very high when we are doing any of the security analysis. Right now, the personal data is one of the topmost asset. So in that case, so privacy, how we can look from a stride perspective. That is what is this slide is about actually. So if you see, these are some of the privacy aspects what we need to from a GDPR or any other privacy laws, right? Data minimization, integrity, confidentiality of the data, legitimacy, transparency, accuracy, minimize storage duration, purpose limitation, all these things happen, right? So what is the threat each of these can face from an attacker? So public, that is confidentiality leak, non-compliance and inconsistent data, that is lack of control, lack of awareness. So these are some of the threats which can be there. And what phase this can be achieved by the attacker. And when we are doing a threat modeling, right? So what elements this privacy has to be analyzed more detailed. So data store and external interface will have an applicability to the privacy, where because most of these things either are data store or external interface where the leak can happen from the personal data. So that is what it is actually. So in the subsequent slide, when Sumit explains, he will give an overview about one of the example where how this privacy is applied in our system and these things. And then later we'll see the attack tree analysis and other important industry differences. So
Yeah,
Sumit,
thanks, Harsa.
yeah.
Yeah, thanks, Harsa, for covering the detailed information about the stride. So here I'll be covering like the tools what we have and how it is integrated the complete stride analysis as well as the change information. So here, like the stride, as a name suggests, like it covers the various attack patterns like spoofing, tampering, reputation, information disclosure, denial of service, elevation prevention, as well as a privacy. So as like the we say a DFD data flow diagram, which is having a various component like the external interactor, process, data storage, the data flow. These are being mapped to a various attack pattern of the stride, spoofing, tampering, as well as like we have considered the privacy, which is also one of the important factor nowadays. Okay, so here I have taken a one simple example of library cloud based library system having a component like external interactor will be like a browser, the internal component will be like a web controller which will be serving the request from the browser. Then will be a user services mostly used for the user at registration purpose, library service. Both are interacting to its own respective database, like a user database for user registration and for the library database for the library service. So this is like an example of a simple cloud based library system. Here we have considered the different kind of communication using data flow, like for security, suppose like we are using HTTPS. So the connection is being shown with the HTTPS over that. And for the database access using the JDBC with the SSL enabling. So here, like a browser is an external interactor, and the all other system we have defined trust boundary, cloud trust boundary. Over that, there are multiple instances which is running. So each instance will be separated with its own trust boundary and showing the communication between that. So this is simple DFD where that how the data will flow over the deployment strategy. Yeah, next slide. So as like we have seen after drawing the diagram, the tool, what are the tool sec design tool, what we are having, there is a threat analysis. So it will automatically generate all the components like we can see over the left panel, the browser, then the data flow interaction, the process, whatever we are having, the data store. With that component, it will also show the status, like whether it is completed or not, and like if something which is partially filled or still in progress. and like with the red color it will show still pending to be updated. So like as we are doing the change, any change in the component or the data flow in the diagram of the deployment, this will directly being like updated here. Also the status again will change from green to red. If new component comes, it will show as a red that we have to do a further analysis. So this change will automatically get interacted to this. And okay, so over that right panel it will provide a detailed description about the attack pattern. Like for the browser here as an example, it is a style attack pattern being considered like a spoofing, reputation, privacy. So these are the three attack pattern which is being considered. And down for each attack pattern it provides like a detailed analysis, like if there is being a spoofing, what can be the impact if it is being our system being this component is being spoofed by like a browser being spoofed by some attack APIs. Then the existing mitigation what we have, like as shown already, like we are using HTTPS as for secured one. And then the exploitability here, it provides more information like how the system can be exploited using the knowledge base. So one way is like we can draw an attack path that we'll cover down the session. Then another is like a view thread. So like for the spoofing for this interactor, it will automatically provide a window where we'll like with a mind map that what are the different attack pattern is possible, and with the categorization, and those can be further analyzed, that will show down. Then the next section where it will cover the detail is the proposed mitigations, like how we can avoid those attack, what are the different mitigations possible, those we can track it here. Also like since the knowledge base is integrated, there is like a view mitigation, what are the different mitigation which is available in our system that we can see, and the recommended scheme which is like best practices. So all those things it will we can readily see here, and then we can just document okay what all things we need it. Okay, next slide. So similar to that browser, like I've considered another element like library database. So here also like it is mapped to multiple elements of the stride: tampering, reputation, information disclosure, denial of service, as well as privacy. So here also like similar for a detailed analysis it can be done. So it is like a partially filled. We can see that for each element, tampering it is filled, reputation it is in progress. So those status for each analysis is also shown over the tool. So after that is being saved and filled for the progress, this will become like a green color over the left panel. So here, like with the detailed analysis, we can provide for each impact, existing mitigation, like exploitability, what are the risk level, whether it is a high, low, or a no impact based on the case to case. So this is like what we can put in the tool. Yeah, next slide. So, like I was speaking about the view threads, which will connect to the knowledge base. See, this knowledge base is being created with the um, uh, library pattern of different attacks like OWAPs, MITRE, which Harsh has already covered previously. So, with this information, it is being categorized like authentication, identity management. So, with a different category, what are the different attacks? It will just organize in this database. There is another view which will be used to check the threat, like we can see a mind map on the right down corner, which is also being generated for the different attack. So here, like for the category, like for data storage tampering, it will then further subcategorize to what are the different attack is there, then with the detailed information about each attack, how it is possible, how it can be done. So this mind tree will be useful to define the exploitation to the component or the system. Yeah, next slide. So with this complete analysis over that tool, we can generate a detailed report, like here as a Word document covering that the data flow diagram, specifying each element, the descriptions, and its impact. It will also generate automatically a set of requirements like which we have considered as a proposed mitigations. And then there is a further section where we can do a detailed design implementation, like a high level design for those mitigation for the system. So this document covers the complete details about the security perspective, which we have considered during the analysis and integrating the design. Okay, so if there is any change like in the data flow, so this document will be regenerated, integrating all this information again. This is one of the most important advantage we have with the tool, that we no need to relook, redo all the things, write the document again, check manually all the impacts. Yeah, over to Harsha.
Thank you. Thank you. Thank you, Sumit. So I think we have only few minutes of time. Just to take you through one important differentiator for the attack tree, right? So for the attack tree analysis, first, usually we start from, for example, there are some situations where we start from a web application as an attack root node. So here the differentiator which we brought in is, first we need to identify the valuable assets. What is that we don't want to get compromised? Is it a personal data, account data, key services, or all of them? Second, we need to identify the risky and critical modules, like what can compromise of which can lead to the compromise of valuable assets. So, and once we draw the attack tree, right, the valuable assets should always be in a root node. And when we progress, so one thing what we'll observe is one step above the leaf node will be the risky modules. So if these risky modules are secured, then the valuable assets will be secured. So that's an analysis actually. So if we think from this perspective, the attack tree, what we have observed is when we draw this attack trees, right? So it is more practical, and then we are able to understand which modules we have to work more closely to see that there is no vulnerabilities involved. So that is one point. So and conclusion part from a test scenario generation, right? So we have seen impact, mitigation, exploitability, attack paths, all this, right? So all these things are taken by the system automatically. So this can be done by simple implementation with some analysis of the industry threat patterns, right? So your test case library is mapped, and then automatically scenarios will get generated. Some manual data points will be added. So then after that, we have a central automation platform with the snapshot I'll be showing. So that platform will take almost, whatever the scenarios which can be automatically executed, right? It will get imported automatically. And then we can execute them. So it is more so you can say it is one kind of a DevSecOps achieved from the threat modeling perspective, actually. So, and then some additional cases will be automated and integrated to the same platform. So this is one simple screenshot where the system, right, whatever the system returns, all the static analysis like secure coding analysis is also integrated, where the code base automatically gets scanned with the applicable rules, and then vulnerabilities are identified. And this is the test execution part what we are talking about, the platform where, or we can just at one click, based on those scenarios, it will be imported here. At one click we can run the scans and other things with respect to known vulnerabilities, with respect to redline, with respect to special scans like a container scan and fuzzing services. So that is about it. So just to conclude, the key thing what we are trying to say is any team, right, when we are looking at the threat modeling, we should not look at it as a standalone. So we should find an integrated approach, like with MITRE and other vulnerabilities integrated approach, to ensure that the whole flow is going very smoothly, and then we are getting the leverage of this particular threat intelligence, which is openly available as a community, right? So that threat intelligence, if we utilize, we can secure our products much faster and easier way. So all teams have to look at integration of this threat intelligence to their threat modeling to make it more seamless. And then automatic test scenario generation is always good. So, and change management gets simplified, and then report generation also is simple. So these are the key things. So considering the problems what we had after this system has been implemented, right? So most of those problems got addressed actually. So that's from our side actually. Thank you. I think we just finished on time.
Thank you all.
Yeah. Any questions? So we have attached one reference slide for the later reference, actually, the pyramid of pain, and then how the MITR maps to cyber kill chain and other things actually that you can refer later. Yeah.
In case we have any questions, we'll be emailing them to you, and we can have a conversation there. No
Okay.
questions
Sure.
as of now.
Sure.
Thank
Sure.
you so much. That was very insightful.
Thank you. Thank you.
Thank you.